Hi, I'm Hanna Kaleova. I'm Director of Clinical Research at the Physicians Committee for Responsible Medicine, and I have some fascinating findings to share with you that have just been published in JAMA Network Open. Excess body weight is associated with insulin resistance and leads to type 2 diabetes and other major health problems. What's the solution? Obviously, dietary interventions play a major role when helping people lose the excess body weight. But what's the most efficient one? What's the one dietary intervention that will address the underlying causes of obesity and diabetes? And that was the topic of our study. We recruited 244 participants who were overweight, and we randomized them into two groups. One group was following a low-fat vegan diet, no animal products, and keeping the fat content up to 20 to 30 grams per day. The second group was following their usual conventional diet for 16 weeks. So what did we do over the course of 16 weeks? At baseline and at week 16, we measured body weight, but also body composition and muscle and liver fat using magnetic resonance spectroscopy at Yale University.
But what we're doing is called NMR spectroscopy. So it's not an image, you get signals from different molecules in the body. We can measure glycogen in the liver, we can measure fat in the liver, we can do the same thing in muscle and in different other organs. So we decided as a collaboration to say let's have this as an outcome, and a really hardcore outcome of dietary interventions of different kinds, and see if it has an effect on what we think is really the cause of insulin resistance and diabetes, the fat in the liver and the fat in the muscle.
We were also measuring the insulin sensitivity and the post-meal metabolism, the thermic effect of food, the amount of energy expenditure that increases after meal intake. Because after we eat a meal, we increase our energy expenditure, but it also depends on the meal composition. How much are we able to increase the energy expenditure? How many calories are we able to burn after a meal? So we invited the participants to come in early in the morning, and we were tracking their post-meal metabolism for 3 hours. And we were also measuring their glucose tolerance after a standardized meal. What we found out was pretty fascinating. After 16 weeks of a low-fat vegan diet, the participants increased their post-meal metabolism by 14%. That means that they were burning 14% more calories after the same meal compared to their baseline assessment. The participants lost about 6 kilograms of body weight. That would be around 14 pounds of body weight, and 2/3 of it were due to fat loss. They also lost a lot of visceral fat, the fat around the inner organs. The fat content in their liver was reduced by 34%, which is a marked reduction. The muscle fat content was reduced by 10%, their insulin resistance dropped, and these changes, the reduction in muscle fat and liver fat were also associated with changes in insulin sensitivity. Their insulin sensitivity went up, which is a positive finding, because we know the insulin resistance, when the cells are not responding to insulin that well, is the underlying cause of diabetes. So we improved their chances of not developing diabetes in the near future. This study also addressed the underlying mechanisms behind insulin resistance. It's the fat that's stored inside the muscle and liver cells that's the underlying cause of insulin resistance. And we showed in this study that a low-fat vegan diet is effective in addressing this underlying cause of diabetes and insulin resistance. So in conclusion, it was a low-fat vegan diet that reduced body weight, reduced fat mass, visceral fat, also the muscle fat and liver fat, and increased the post-meal metabolism and the thermic effect of food.